Are you finishing up the methods course? Let's go through one of the trickiest topics, confidence intervals. Now, oftentimes we might have a full population and we're interested in a certain characteristic. For example, what percentage of the population smokes? Now, obviously, it's very difficult to ask every single person, okay, do you smoke, do you smoke, do you smoke? And therefore, it's very difficult to get an exact value of the population proportion, the proportion of the population who smokes, okay? So what we tend to do in statistics is we actually take a representative sample of the population and we ask everyone in that small sample whether they smoke or not, as an example, okay? And because of that, we can measure, well, the percentage of people in that sample who smoke. In this case, that would be called the sample proportion, all right? Now, we can use the sample proportion to actually estimate the population proportion. And there are two ways in which we can do this. First of all, we can take what is called a point estimate, where we literally say that the population proportion is equal to the sample proportion. The issue with that is that it's inaccurate. Just because 20% of people in my sample smoke doesn't mean that 20% of everyone smokes, right? So that's why there's a second approach, which is taking an interval estimate, which might be such as between 10% and 30% of people smoke. And that's a little bit more precise. And that can be represented through this normal distribution curve that you can have here, whereby rather than taking that singular, p hat value or sample proportion, we actually take a whole range, which is represented by that arrows on that normal distribution curve, okay? So now the question is, how do we calculate that interval estimate? And there's three key values that you need: your sample proportion, your sample size, and then the percentage confidence, okay? Now, the actually way that we use those values together is shown in this big formula, and I know it's very scary, but really all it's saying is that we have the mean and we have the standard deviation, which is calculated using the sample proportion and sample size. And then finally, we have K, which is actually based upon your percentage confidence. And the way you calculate that value of K is by, once again, using that knowledge of the normal distribution curve shape. A 95% confidence interval, for example, will have 95% of the area under the curve between minus K and K. And then sort of what you can do is you can take the area to the left of K using inverse norm and stuff, and you can solve for K on your CAS pretty much, okay? And if you do all of that, then you have all the values you need to calculate your confidence interval. And all you need to do now is use the formula, sub your values in, and boom, that's your confidence interval. If you want a part 2 to this difficult topic, let me know in the comments below. See you guys.